Welcome to my channel everyone. Let us discuss about law of multiple proportion as proposed by John Dalton in the year 1804. This is the statement which states that when two elements combine to form two or more compounds, then the masses of one of the element bears or the masses of one of the element which combines with the fixed mass of the other element bears a simple whole number ratio to another. ये तो रहा आपका स्टेटमेंट. इस स्टेटमेंट का जो मीनिंग है वो क्या है? When two elements combine, चलिए एग्जाम्पल क्या है? कार्बन एंड ऑक्सीजन. To form two or more compounds, यहाँ पे दो कंपाउंड दिख रहा है, कार्बन मोनोऑक्साइड CO एंड कार्बन डाइऑक्साइड CO2. मतलब कार्बन एंड ऑक्सीजन कंबाइन करके दो कंपाउंड दे रहे हैं, एक से ज्यादा कंपाउंड दे रहे हैं. एक्चुअली वो क्या है? कार्बन मोनोऑक्साइड एक है, कार्बन डाइऑक्साइड दूसरा है. Then the masses of one of the element which combines with the fixed mass of the other element. तो इन कार्बन मोनोऑक्साइड जब हम देखेंगे by mass 12 gram of carbon combines with 16 gram of oxygen, and in carbon dioxide 12 gram of carbon combines with 32 मतलब 2 into 16 gram of oxygen. That means the masses of one of the element जो यहाँ पे oxygen है that combines with the fixed mass of the other element, वो fixed mass है कार्बन का जो कि 12 ग्राम है दोनों केसेस में, bears a simple whole number ratio. मतलब 12 ग्राम ऑफ कार्बन के साथ ऑक्सीजन जो कंबाइन कर रहा है इन CO एंड इन CO2, इस ऑक्सीजन का दोनों कंपाउंड में रेशियो जो निकलेगा वो होगा सिंपल होल नंबर रेशियो. So here we can see 12 parts by weight of carbon combines with 2 into 16 parts by weight of oxygen in CO2 and 16 parts by weight of oxygen in CO. तो ये हो गया आपका फिक्स्ड मास 12 parts of carbon. तो ऑक्सीजन का जो रेशियो है वो क्या है? 2 into 16 in CO2 is to 16 in CO, which is a simple whole number ratio, that is 2:1. Let us check out another question related to the law of multiple proportion. Two elements A and B combine to form two different compounds X and Y. Now how is this X and Y? 1 gram of X, it contains 0.639 gram of A and 0.361 gram of B, whereas 0.5 gram of Y that contains what? 0.233 gram of A and 0.267 gram of B. Now you have to show that this data is in accordance with law of multiple proportion. Now here we are not seeing any fixed parts by weight or fixed mass of any element like we have seen in CO and in CO2. Here the masses are different. So what we can do is here 0.639 gram of A combines with 0.361 gram of B. So we can bring it down to unit mass. Therefore, 1 gram of A will combine with unit mass, how much? 0.361 by 0.639 gram of B. Now this will come out to be say 0.565 gram. I have it ready, so I have given it to you. 0.565 gram. Like this only you can see that 0.233 gram of A combines with say 0.267 gram of B. So we just need to reduce it or represent it to again unit mass of A. 1 gram of A. If we see that we are not having the same mass of the element, we have to bring it to the same mass. So unit mass of the element combines with how much part of the other element that we are finding. So combines with, similarly, what we'll do, 0.267 divided by 0.233, and that comes out to be say 1.146 gram of B. Now our work will remain what? This part that we got, 0.565 gram of B in this compound X and 1.146 gram of B in this compound Y. Uska jo ratio hai, that we need to find out, because the weights of B that combines with the fixed mass of A or the fixed weight of A, and their ratio is 0.565 is to 1.146. That means we'll find the ratio of this two, and we will see whether it is coming up to be a simple whole number ratio, and I think yes, it comes out to be 1:2. Please check out for your own. In Gay-Lussac's law of combining volumes, the statement says at a given temperature and pressure, मतलब कोई भी particular temperature and pressure condition में अगर gases combine करते हैं, when gases combine, they do so in volume, वो volume के हिसाब से combine करते हैं, which bear a simple whole number ratio to each other and also to the वॉल्यूम ऑफ गैसियस प्रोडक्ट्स. मतलब अगर गैसेस कंबाइन कर रहे हैं और जो प्रोडक्ट दे रहे हैं वो भी गैस हो, देन दे रिएक्ट और दे कंबाइन इन वॉल्यूम, पार्ट्स बाय वॉल्यूम. H2 gas combines with Cl2 gas to form 2 moles of or 2 volumes of HCl. Right now I'll not introduce the concept of mole, but we'll see as per the equation, 1 part by volume of H2 combines with 1 part by volume of Cl2 to form 2 parts by volume of HCl. So the ratio of the gases, the reactants and the products as per the volume combination is 1:1:2. As an application of Gay-Lussac's law of combining volumes, we get a question here. Calculate the volume of H2 required to prepare 20 liter of NH3 ammonia as per the reaction. That is, we can see that gaseous reactants N2 and H2, they are combining to give gaseous product ammonia. And what is the ratio of the volumes? This is 1:3:2. 1 volume, 3 volume and 2 volume over here. So if I say that if it is 3 volume of H2 combining with 1 volume of N2 to form 2 volumes of NH3, then calculate the volume of H2 required to prepare 20 liters. So I can consider this as 20 volume. So in that case, how will I solve it? I'll consider the volumes, the unit of the volumes to be liters, and then I will say, as per the question, 2 liter of NH3 is produced from 3 liter of H2. Therefore, 20 liter of NH3, plain and simple unitary method, 3 by 2 into 20. This many liter of H2 will be formed. Avogadro's law, at constant temperature and pressure, the volume of a gas is directly proportional to the number of moles of the gas. मतलब अगर टेम्परेचर प्रेशर कंडीशन कांस्टेंट हो तो वॉल्यूम ऑफ द गैस इज डायरेक्टली प्रोपोर्शनल. अगर V है वॉल्यूम ऑफ द गैस, this is directly proportional to number of moles of the gas. If I consider number of moles of the gas to be small n, then V is proportional to n. इसी रिलेशन से मिलता है V1/N1 is equal to V2/N2 for two different conditions. So we can say with this as the Avogadro's law in action becomes what? As the number of moles increases, the volume increases proportionally. That means agar number of moles of a gas increases, then the volume also increases proportionally. Now I'm going to explain to you what actually is number of moles of the gas. ये जो मोल कॉन्सेप्ट है, इसके नाम सुनते ही बच्चे घबरा जाते हैं. हमको घबराना नहीं है, धीरे धीरे समझना है. मोल एक संख्या है. 6.022 into 10 to the power of 23 is considered as 1 mole of any substance. So amount of substance that contains 6.022 into 10 to the power of 23 number of that substance. मतलब 1 mole of atom, 1 mole of molecule या 1 mole of ion, कोई भी entity हो, उसका एक मोल मतलब 6.022 into 10 to the power of 23 number of that entity, चाहे वो atom हो, molecule हो या ion हो. As an example, 1 mole of carbon atom मतलब 6.022 into 10 to the power of 23 number of atoms of carbon. इस number को बताया जाता है Avogadro number as it was given by Avogadro. So the number is known as Avogadro number. It is represented as Na. So वैसे ही 1 mole of oxygen molecule मतलब 6.022 into 10 to the power of 23 molecules of oxygen. This is 1 mole of oxygen molecule and this is 1 mole of carbon atoms. तो थोड़ा बेहतर समझे. अमोनिया का जो केमिकल फॉर्मूला है, it is NH3. अगर हम 1 मोल ऑफ मॉलिक्यूल ऑफ अमोनिया की बात करें तो उसमें एवोगेड्रो नंबर ऑफ मॉलिक्यूल्स है 6.022 into 10 to the power of 23. वैसे ही 1 मोल ऑफ मॉलिक्यूल ऑफ अमोनिया इज मेड अप ऑफ 1 मोल ऑफ नाइट्रोजन एंड 3 मोल्स ऑफ हाइड्रोजन एटम्स. तो नंबर ऑफ नाइट्रोजन एटम हो गया 1 मोल के बराबर. So 6.022 into 10 to the power of 23 एक मोल के बराबर एटम्स है और 3 मोल के बराबर हाइड्रोजन एटम्स है. So 3 into 6.022 into 10 to the power of 23. तो 1 mole of molecule of ammonia will contain 1 mole of nitrogen atom and 3 moles of hydrogen atom. 1 mole of a gas मतलब वो गैस at STP can occupy 22.4 लीटर वॉल्यूम. STP क्या होता है? स्टैंडर्ड टेम्परेचर एंड प्रेशर कंडीशन. तो उसमें टेम्परेचर कंडीशन कितना है? 273.15 केल्विन और प्रेशर 1 बार एज पर इंटरनेशनल यूनियन ऑफ प्योर एंड अप्लाइड केमिस्ट्री एज पर IUPAC. Now, this volume that corresponds to 1 mole of a gas is known as molar volume and its value at STP is 22.4 liter. Now, 1 mole of any substance is related to the mass of its atom or the mass of its molecule. So, it is the amount of substance having mass equal to gram atomic mass और ग्राम मॉलिक्यूलर मास. एटम की बात करें तो ग्राम एटॉमिक मास, मॉलिक्यूल की बात करें तो ग्राम मॉलिक्यूलर मास. जैसे 1 मोल ऑफ कार्बन एटम है, इट्स इक्विवेलेंट टू 12 ग्राम. दैट इज द एटॉमिक मास एक्सप्रेस्ड इन ग्राम. 1 मोल ऑफ ऑक्सीजन मॉलिक्यूल डाई एटॉमिक होते हैं. एक एटम के लिए 16 ग्राम. सो 2 एटम के लिए 2 into 16 ग्राम विच इज इक्वल टू 32 ग्राम. So this is also considered as the molar mass. We can sum up and say 1 mole of any substance contains 6.022 into 10 to the power of 23 number of that substance or that entity. It can be atoms, molecules or ions. 1 mole of a gas at STP can occupy 22.4 liter of the volume and that corresponds to the molar volume. The mass which is equivalent to the gram atomic mass or gram molecular mass is same as the molar mass of the atom or molecule. So we can technically define mole as amount of substance containing as many elementary entities. Entities means atoms, molecules or ions or particles, as in exactly 12 gram of C12 isotope. अब हम जब एवोगेड्रो लॉ क्या है हमने देख लिया, नंबर ऑफ मोल्स क्या होता है दैट आल्सो वी हैव सीन, तो थोड़ा सा अप्लाई करके देखें. चलिए, suppose you have 2 moles of oxygen gas occupying a volume of 44.8 liter at a certain temperature and pressure. What volume will 3 moles of oxygen occupy under the same conditions? So we can see it has relation of volume of the gas with respect to the number of moles. So we can use Avogadro's law, and the formula that we have seen is V1 by N1 is equal to V2 by N2. Placing the values, we can find out the unknown. So I think it's pretty easy, isn't it? Let us try to solve these things. 3 questions, not very difficult, but I'm not going to solve for you. I'll tell you how to do so. How many moles of H2SO4 are present in 4.9 gram of H2SO4? So first you have to find out the molecular mass of H2SO4. 2 into atomic mass of hydrogen, 1 into atomic mass of sulfur, plus 4 into atomic mass of oxygen will give you the molecular mass. That corresponds to 1 mole because it is same as the molar mass when it is expressed in moles. So if that corresponds to 1 mole, 4.9 gram corresponds to how many moles? Quick, you can do it. Second one, calculate the number of atoms in 1 mole of phosphorus molecule, and phosphorus molecule exists as P4. So how many atoms are there? I have told you like this in the examples of oxygen, molecule, O2. So apply and solve it. 0.05 gram of water, same as the first one. H2O is your water. So molecular mass will be 2 into the atomic mass of H plus 1 into the atomic mass of oxygen. So when you write molecular mass, you can give the unit as gram, but when you are writing the molar mass, keep in mind the unit will be gram per mole. So here we can work out with the molecular mass only. So the molecular mass of water you need to find corresponding to 1 mole and corresponding to how many atoms. This you need to solve a bit. Try and solve it. Check your answers. Answers are giving over here. Lead nitrate. This is the formula of lead nitrate. Decomposition. It's actually a thermal decomposition. So 2 PbO plus 4 NO2 plus O2 is the product. How many moles of lead nitrate is needed to produce 22.4 liter of oxygen as at NTP? So here we can see it is 1 mole produced from 2 moles of lead nitrate, and 1 mole of the gas corresponds to 22.4 liters. That's a molar volume. Yes, you can surely solve it and check your answers. Thank you all of you.